Okay, so we've got this functional here. It's the cube root of x squared plus 2y of x plus y prime of x squared. Now, we can see here that as this is a functional, this function y is not a variable, y is a function of x. And the same here, the derivative of y is also a function of x, obviously here squared. And what we need to find is the derivative of this term here with regards to x. Now, we can't just simply plug in the derivatives of each term under the square root like we would in normal calculus. We need to apply some sort of chain rule. So what we can say is the derivative of f with respect to x is, we use partial derivatives and then the derivative of each partial. So partial derivative of f with respect to x, and that takes care of the x term because that's going to be a function of x. Then what we need then is the partial of f with respect to the y. So with respect to the y, then by the chain rule, because it's a function of x, we need to multiply by the derivative of x in that term. So that we do there now is derivative of y with respect to x. So that's like a multiplication of the two, basically the chain rule. And then the same will involve this one here. So we've got the partial of f with respect to y prime, and then we take the derivative of y prime with respect to x. Okay, so now what we could simply do now is just go through this term here, plug in all these values and see where we get to. But we could also simplify these up a little bit. So we can now say the partial of f with respect to x plus partial of f with respect to y, and then dy dx, just to try and get it in the similar sort of terms as we got here, I'm just going to write that as y prime. So just changing the style of the notation. And then here, partial of f with respect to y prime. So we take the partial of that with respect to y prime and then multiply it by the derivative of y prime with respect to x, which will then give us y double prime. So our goal now is to find these three partials, and then we can work out this total derivative of here. So partial of f with respect to x. So let's just put a little line here. So partial of f with respect to x. Okay, so if we go inside the square root term using the chain rule, we can take the derivative of this. These will be constants, so they will stay. And then we need to take care of this cube root term. So what we can say is that this term here, if we just rewrite that to x squared plus 2y plus y prime squared, we know that's all functions of x. And because it's a cube root, we say it's to the power of 1/3. So that's going to make it easier to work out our partials. So let's take the partial with respect to x. So this term here will appear in the denominator, just by a good old-fashioned calculus 1 class. So we've got x squared plus 2y plus y prime squared. And then the 1/3, if you subtract 1 from that, that would become 2/3, minus 2/3. So the 2/3 will be a positive 2/3 in the denominator. The 1/3 will come out front, so that's 1/3. And now what we do now, using the chain rule, take the derivative of x squared, which is just 2x. So that's 2x. So now what we can do is bring this 3 down here, leave the 1 on top, well that will just get cancelled out. So then that will leave us with this as our final answer for the partial with respect to x. Okay, next term we need is the partial of f with respect to y. So let's just write that out on here. Okay, so we're going to end up with the same denominator by the chain rule. So the 1/3 will come out front. The inside term will then be in the denominator with the 2/3 as it was before. So that's x squared plus 2y plus y prime squared to the power of 2/3. And then now we multiply by the derivative of 2y with respect to y. So that would just become 2. So if we put the 2 there, and then this third, we'll bring the 3 down in the bottom. Cross out this third. 2 times 1 is just 2. So that will then give us our partial with respect to y. Okay, now we need the partial with respect to y prime. So let's just write that in here as well. So same again, partial of f with respect to y prime. So we're going to end up with the same denominator as before. So let's just go straight in with the 3. And that's x squared plus 2y plus y prime squared to the power of 2/3. Chain rule is going to work just the same for all of these inside terms. But now all we're going to do now is multiply by the derivative of y prime squared, which is just going to be 2y prime. Okay, so now what we can do is we can now go onto this formula here and see where that takes us. So now we've got partial of f with respect to x, that's this one, so let's write this one in here, 2x 3 x squared plus 2y plus y prime squared to the power of 2/3. And then we're going to add the next partial, which is just 2, over this same denominator, 3x squared plus 2y plus y prime squared to 2/3. And now we're going to multiply that by y prime. So then that becomes 2y prime. And now we're going to do this partial, which is here. So again, we're going to add, so 2y prime, 3 times x squared plus 2y plus y prime to the power of 2/3. Another better looking 3. And then multiply by y double prime. Okay, so now we can just simplify this up, which is looking pretty straightforward because our denominators are all the same. So the algebra for this is straightforward. Then we're just going to add on all the numerators. So now we can say partial of f, the total derivative of f with respect to x is 2x plus 2y prime plus 2y prime y double prime. So we can maybe factor that out a little bit and put that as a 2. X plus y prime plus y prime y double prime. And then we just multiply by 3 times x squared plus 2y plus y prime squared to the power of 2/3. And that's going to give us the answer to the total derivative of this. Okay.